Hello everyone, welcome to Neso Academy. In the previous lecture, we have understood the history of machine learning. And now in this lecture, that is well-defined learning problem, we are going to understand what is a well-defined or a well-posed learning problem. So the topic for this lecture is well-defined learning problem. Let's get started. Do you know this famous personality? He is Tom Mitchell, a world-renowned computer scientist. In 1997, Tom Mitchell gave the formal definition of machine learning using three mathematical variables, t, p, and e. Now I am going to show you the simplified version of his formal definition. A computer program is said to learn when its performance p improves at a specific task T over the time by gaining experience E. This is the simplified version of the original definition of machine learning given by Tom M. Mitchell. This definition may sound a little bit theoretical, but the idea behind this definition is very simple. According to this definition, a computer program or a machine learning program or a machine learning system is said to learn when it becomes better at a specific task over the time by gaining some experience. Now suppose you have started a very new activity today. Do you expect yourself to be outstanding in that activity on the day one? Not at all. But over the time, gradually, by gaining some experience, you will definitely become better at that specific activity or task. That's what represented using this definition. A machine learning program also improves its performance over the time at a specific task by gaining some experience. Now, why I have explained you this definition? Because this definition lays a strong foundation for our today's topic, that is well-defined learning problem. Now let's understand what is a well-defined learning problem. It is a problem in which the task T, performance measure P, and experience E are clearly specified. So, if we are able to identify the task, performance measure, and the experience in a particular problem, then that problem is called as a well-defined learning problem. Now, what is task, what is performance measure, and what is experience? Task, as the name suggests. Task means what the system needs to accomplish. What our machine learning system needs to do. What is the job of the machine learning system? That is the task. What is performance measure? Performance measure is an evaluation criteria that checks the performance of the machine learning system on the given task. And what is experience? Experience is the data from which the machine learning system understands the patterns and the features. So, the task, performance measure, and the experience should be clearly mentioned or specified in a well-defined learning problem. Let's see the second point. A well-defined learning problem makes it easier for the learning system to understand what it needs to do, how success will be measured, and what data it can learn from. So this point is basically the simplification of this definition. It means that a well-defined learning problem makes it easier for the learning system to understand what it needs to do, that is task, how success will be measured, that is performance measure, and what data it can learn from, that is experience. Now, can you tell me the three features or the three components of a well-defined learning problem? The three key features or the key components of a well-defined learning problem are task, performance measure, and experience. Now we are going to understand these three components of a well-defined learning problem one by one. The first one is task. Task describes what the system needs to accomplish. Basically, what is the job of the machine learning system? What is the work assigned to the machine learning system? That is called task. Tasks should be well defined and clearly understood. What does that mean? It means that in a well defined learning problem, the task should also be well defined, and we should be able to understand the task clearly from the problem. So it means that in a well defined learning problem, the task cannot be unclear or confusing. Let's see a few examples. The first example is image classification. What is image classification? To classify or categorize images into two or more categories. Like in lecture number 1, we have classified images into two categories, cats and dogs. So what can be the task associated with an image classification problem? Obviously, to classify the images into two or more categories. That is the task. The second example is handwriting recognition. In a handwriting recognition problem, the task is to recognize the handwritten words or numbers. The third example is spam email detection. Spam email detection means to detect whether the emails are spam or not spam. So the task would be to classify or categorize emails into two categories, spam emails and not spam emails. The fourth example is house price prediction. In house price prediction problem, the machine learning system has to predict the prices of the house. So that is the task associated with this problem. In this way, we are done with the first feature of a well-defined learning problem. That is task. Now the second feature is performance measure. Performance measure is a quantitative metric that evaluates how well a system performs a task. What does that mean? It means that a performance measure is a quantitative metric or a numerical indicator that evaluates or checks how well a system performs a task. So it basically checks the performance of the system on the given task. Performance measure assesses effectiveness, accuracy, or success in meeting desired outcomes. It means that the performance measure assesses the effectiveness, how effective the machine learning system is on the given task. It also calculates the accuracy or the success rate in achieving the desired outcomes. This is performance measure. Now let's see a few examples of performance measure. The first example is a chess playing program. That means the machine learning program is playing the chess game. Now, how do we evaluate the performance of this particular machine learning program? By calculating the number of games it has won. So, for a chess playing program, the performance measure is the number of games it has won. More the number of games it will win, more will be or better will be its performance accuracy. The second example is spam email detection. And the performance measure for this particular problem is number of emails correctly classified. More number of emails correctly classified, better will be its performance. The third example is house price prediction. That is, to predict the prices of the house. Now, the performance measure for this particular problem is how close the predicted price is to the actual price. So in house price prediction, we already have the actual prices of the houses, and we also let our machine learning program to predict the prices of those houses. Now, we will check how close the predicted prices that are predicted by our machine learning program is to the actual price. So we will match the predicted prices and the actual prices, and the difference is the performance accuracy. If the difference is very large, it means the performance is bad. And if the difference is very small, that means the performance of our machine learning system is very good. So in this way, we are done with the second feature of a well-defined learning problem, that is performance measure. The third feature is experience. Experience refers to the data from which the system learns. That means the data set from which the machine learning system learns the patterns and the features. That data is called as experience. The system improves its performance by learning from this data over the time. As I have already explained you, the machine learning system will learn the patterns, features, and relationships from this data, and over the time gradually, it will improve its performance at the given task. Now let's see a few examples of experience. The first one is movie recommendation. That is a movie recommendation system. Now to recommend movies to users, what type of data the machine learning system will require? The user ratings and the watch history. On the basis of the ratings given by the user to different movies, as well as the watch history of the user, will determine what type of movies will be recommended to the user by the machine learning system. The second example is spam email detection. Now to classify the emails into two categories, that is spam or not spam, what type of data will the machine learning system require? Previously labeled emails, spam or not spam. So machine learning system will require a data set which contains lots of emails along with the specified category, that is spam or not spam. From that data set, machine learning system will learn the patterns, features, and relationships. And after that, it will be able to classify a new email into the categories like spam or not spam. The third example is house price prediction. That is, to predict the prices of the houses. Now, what type of data will the machine learning system require to predict the prices of the houses? Historical house price data. That means a data set which contains thousands of houses, including their features and their actual prices. Now, the machine learning system will be trained on that particular data set so that it can learn the relationships between the house features and the house prices. And on the basis of that training, it will be able to predict the price of a new house. So in this way, we are done with the third and the last feature of our well-defined learning problem, that is experience. So till now, we have discussed Tom Mitchell's definition of machine learning, well-defined learning problem, and the three features of well-defined learning problem. Now, I will give you very simple examples of well-defined learning problem, and you need to tell me the task, the performance measure, and the experience associated with that particular problem. The first example is email spam detection that we have already discussed multiple times. I am sure you have seen this interface while accessing your Gmail account. This is the spam folder, which contains the unwanted junk emails called as the spam emails. And this inbox folder generally contains the emails that are not spam. Now, our machine learning system needs to classify the emails into two categories, spam and not spam. Now tell me, what is the task associated with this particular well-defined learning problem? It's very simple. The task is to classify the emails into two categories, either spam or not spam. Now, what is the performance measure? We have just discussed. Performance measure is the number of emails correctly classified. That is called as the accuracy of classification. More the number of emails correctly classified, better will be its performance. And the last one, that is experience. Experience or the data will be the collection of previously labeled emails, as we have just discussed while discussing the experience. Now let's take the second example. Example number 2, house price prediction. That means the machine learning system needs to predict the prices of the houses. So what is the task? Again, very simple. The task is to predict the price of a house. What will be the performance measure? Performance measure is how close the predicted price is to the actual price of a house. And if I talk about the experience, we have just discussed experience or the data will be the historical house price dataset. So these were the two examples in which we have identified task, performance measure, and the experience from the given well-defined learning problem. And in this way, we are done with our topic, well-defined learning problem. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.